Welcome to TechDaily.ai. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com for more info. Today we're diving into a question that props up quite a lot when you're looking at your computing needs. What's the real difference between a regular PC, a server, and maybe even a workstation? It can feel like you're wading through, a sea of jargon sometimes.
Yeah, absolutely.
But our mission today is really to cut through that noise. We want to help you make genuinely informed decisions, whether it's, say, for your home setup, a growing small business, or maybe you're just curious about the tech.
Exactly. And we've gathered some, I think, fascinating insights to help unpack all that. We want to help you understand not just what these systems are, but maybe more importantly, why their distinctions matter so much.
Right.
What's often surprising, I find, is how these differences, even when they seem kind of fuzzy at the edges, they really impact everything from raw performance and reliability right down to, well, your electricity bill.
Okay, let's unpack this then. Let's start with maybe the most fundamental difference. PC versus server. If you had to boil it down, what's the core purpose each one is designed for?
Okay, so at its heart, a server is basically a computer that provides information and services to other computers, which we call clients, usually across a network.
Right, the client-server model.
Precisely. Think of it like a central hub responsible for sharing data, managing resources, maybe performing complex computations for everyone connected. A personal computer, a PC, on the other hand, is built more for general individual tasks.
Like browsing, gaming.
Yeah, accessing websites, playing games, creating content, just storing your personal files. And it's interesting, isn't it, how many tasks we used to only do on a PC are now, easily handled by our phones or tablets.
True. So if a PC is for individual tasks and a server is for sharing, how does that actually translate into how they operate? Are they built for different kinds of work day to day?
Oh, absolutely. When we talk about a server, we might mean the software, the process running, or we might mean the dedicated hardware running it. But the key distinction is really its operational philosophy.
Okay.
Servers are designed for a continuous 2047 sort of marathon. They're built to run steadily, reliably, for years on end without skipping a beat.
Wow, years.
Yeah, many enterprise servers are engineered to run for a decade without a single reboot. It's a real testament to their design. PCs, though, they're more like sprinters.
Okay.
Built for sporadic use, flexible tasks over shorter bursts. You really wouldn't want to run, say, a consumer-grade mechanical hard drive continuously. They're just not designed for that kind of stress.
Right. It'd wear out fast.
Exactly. And if you try to make a PC run dedicated server tasks, you'll often find it just eats up valuable resources.
That marathon versus sprint analogy really clarifies it. And, this isn't exactly a new concept, is it? The term server in computing has been around for a while.
It has, yeah. It actually dates all the way back to 1969.
Really? 69?
Yeah, appearing in early ARPANET documents. So while the technology has obviously changed dramatically, the basic idea of one machine providing services to others, that's been foundational to networked computing for, well, over half a century now.
That's amazing context.
Yeah.
Okay, so while we're on servers, a lot of people listening might be thinking about managing their own data, maybe at home or in a small office. And that leads us right to a really popular specialized type of data server. NAS, network attached storage.
Ah, yes, NAS devices. They're really convenient solutions, aren't they? Great for backup and file sharing, specifically engineered for storing pretty significant amounts of data. And they often run services, too, like surveillance systems or even media streaming.
So someone might think, why not just hook up a big external hard drive to my desktop? What really sets a NAS apart? What's the key difference there?
I'd say the biggest things are data capacity and resilience. A NAS is designed for, well, big data. They typically come with multiple drive bays, from 2 up to quite a few, and you can often add expansion units later.
Right, you can grow it.
Exactly. Your standard desktop PC, though, usually has pretty limited internal drive bays, maybe 2 to 6 for the standard drives, plus a few M.2 slots nowadays. That really caps its overall storage potential.
Yeah.
And critically, NAS often supports hot swap bays. That means you can easily replace a failing drive and rebuild your RAID array, that's your redundant storage, without even shutting the system down.
Ah, that's huge. No downtime.
It's a lifesaver if you value your data. That's a feature you just don't typically find in a regular desktop PC, where a drive failure often means, well, downtime and maybe some panic.
Definitely panic.
Yeah.
And I guess power efficiency must be a big factor too if it's meant to be on all the time.
Exactly. That's a really important point. Most pre-built NAS enclosures use low-power processors. You see AMD, ARM, Intel chips designed for this. They're specifically chosen to draw less power than a typical desktop CPU. And that's crucial because, while your desktop might not use much power when idle, a system running 24/7 can add up quickly on your electricity bill.
Yeah, I bet.
So often, a purpose-built NAS actually ends up being a surprising long-term saver, even if the initial cost seems a bit higher.
That's interesting. I hear about people repurposing old PCs as a NAS. Is that actually a good idea, or are there, like, hidden drawbacks?
It's totally possible, and yeah, lots of users do it successfully. You can definitely transform an old desktop into a NAS server using various operating systems. Windows, Ubuntu, TrueNAS, Unraid, Open Media Vault, there are options.
So it saves money up front.
It can, yeah. It's convenient and cheaper than buying a new pre-built NAS. But you do need to be aware that running an old PC 24/7, it can be pretty inefficient power-wise compared to a dedicated NAS build.
Right, that power bill again.
Exactly. Some users get creative, though. I know people who've converted old gaming PCs for tasks like running a Plex media server, but they might only turn them on when needed, often using Wake on LAN to save power. If you don't need it on all the time, it can be a decent budget option.
Gotcha. Okay, so we've covered personal use, home offices. But what about dedicated servers for businesses? When does a small business really need to start thinking about something more, well, robust?
That's a great question. For a growing business, a dedicated server often becomes essential as your data and network needs expand. It really simplifies managing multiple computers.
How so?
Well, it provides secure, centralized access to company data and email. It can guarantee consistently fast data access in a way that, cloud services can't always match, especially if your internet connection isn't rock solid.
Okay.
It also significantly improves network security compared to just relying on your ISP's router, and it lets you put really robust backup plans in place. These aren't just nice-to-haves, they're often the backbone of business continuity.
That sounds like a pretty significant investment, though, both upfront and, I imagine, over time. What kind of costs should a business be prepared for?
You're right, it's not trivial. The hardware alone, you're probably looking at an average between, say, $1,000 and $4,000.
Okay.
For instance, a minimal server setup might be around $1,500, maybe $1,600. Something more moderate, maybe closer to $2,000. A more extensive setup with dual processors could easily push towards $4,000 or more.
That's just the box.
That's just the box. And remember, upgrades like SSDs can easily add hundreds more. Then beyond that, the installation often requires an IT professional.
Right, setting up the network security.
Exactly. That can add several hundred to maybe even a few $1,000s because it's more complex than just plugging in a desktop.
So definitely not plug and play. And then there's ongoing maintenance too, right?
Precisely. You should budget for, I'd say, 1 to 10 hours of maintenance per month just for updates, general upkeep. Plus, of course, any costs if hardware actually breaks down and needs replacing. It's an ongoing commitment to keep things running smoothly and securely.
Okay, so given those costs and complexities, how do businesses usually handle getting and managing these servers? Is it always about buying one outright and sticking it in a closet?
Oh, not at all. There are really 3 main approaches. You can rent, you can buy, or you can co-locate.
Okay, renting. What's the deal there?
Renting a server usually means a fixed monthly fee. That often covers the hardware, security, power, cooling, even support. It's predictable. The downside is it can be costlier in the long run. You don't physically have your hands on your data, and, well, you don't own the equipment.
Makes sense. And buying. That gives you full control, but what are the pros and cons there?
Buying means that single upfront payment for the hardware. It gives you full customization, physical access to your data. You might save costs long-term if you keep the hardware for a while.
But the responsibility is all on you.
Totally. You're entirely responsible for all repair and replacement costs. And you have to manage all the security, the networking, the cooling, the power expenses yourself. It's definitely more hands-on.
That sounds like a lot to manage in-house, especially for a smaller business. So what's colocation then? That sounds like a mix.
Co-locating is indeed a hybrid approach. You buy your server hardware, but you host it in a dedicated data center facility.
Ah, okay.
So this gives you the secure monitoring, the stable environment, 24/7 remote access without it being quite a full cloud server. The hardware costs are upfront. You pay monthly hosting fees for the space and power and cooling, but you still leverage the data center's infrastructure. You are still responsible, though, if your hardware fails.
Got it. So it's like owning the car but parking it in a professional, secure garage.
That's a pretty good analogy, yeah. It's a good middle ground for businesses that want ownership but maybe don't have the resources or desire for a full server room on premises.
Now, when we talk about these dedicated servers, this phrase server-class hardware keeps coming up. What does that really mean? What makes it different from the parts in my desktop PC?
Yeah, server class implies a whole different level of power and, crucially, reliability. It's engineered for that marathon we talked about earlier, not the sprint.
So what are the key features?
Common features include things like ECC RAM, that's error-correcting code memory. It's critical because it actively detects and corrects single-bit memory errors on the fly.
Errors that would just crash a normal PC.
Exactly, or worse, silently corrupt your data. Consumer RAM just doesn't do that. You'll also often find redundant power supplies, so if one fails, the other instantly takes over, no interruption.
Nice safety net.
Definitely. Hot swap drive bays, of course, for replacing drives without downtime, and things called baseboard management controllers, or BMCs like Dell's IDRAC or HP's ILO. These let IT pros manage the server remotely, even if the main operating system isn't responding. They can power cycle it, check hardware status, all from anywhere.
So basically, parts designed to fail less often and be way easier to manage when things do go wrong.
That's the core idea. Servers typically use CPUs like Intel Xeon or AMD EPYC or Threadripper Pro. These aren't just faster in some benchmarks. They're built with more cores, support vastly more RAM, have larger caches, and often feature specialized instruction sets, all geared towards continuous, heavy, parallel workloads rather than, say, burst performance for gaming.
And graphics.
Usually pretty basic, actually. Unlike desktop PCs, servers generally don't include high-end graphics cards unless they're specifically built for compute-intensive tasks like AI, deep learning, or scientific simulations that leverage GPU power. For just serving files or running applications, a simple onboard graphics chip is fine.
And they look different too, right? All those rack mounts?
Yeah, most servers are designed for rack mounting in data centers. That standard 19-inch width optimizes space, airflow, and cabling, and lets them benefit from the data center's stable power, fast internet, and controlled climate. All this leads many IT pros to strongly advocate for keeping server hardware separate from your main PCs.
Because they're just built for different jobs.
Exactly. There are power needs, resource demands, uptime requirements. They're just too different. Trying to make one machine do both jobs well often results in it doing both kind of poorly. It's like asking a marathon runner to also win the 100-meter dash.
That makes perfect sense. Okay, let's shift gears slightly and talk about a really powerful concept that comes up constantly when discussing servers and resource management: virtualization. What is it, in a nutshell?
Virtualization basically allows applications and operating systems to use computing resources like servers, storage, networks, without needing to know the physical details, like where they are located or how they're implemented.
So it's like creating virtual versions of hardware.
In essence, yeah. It means you can break up a large physical resource, like a PowerShell server, and share it among many smaller virtual ones. Or, conversely, you can combine many smaller physical resources into one larger, logical, manageable pool.
Okay, why is this such a big deal? What are the main advantages?
Oh, there are several huge advantages. First, sharing. You can take one beefy physical server and slice it up into multiple smaller, usable virtual machines, or VMs, each acting like its own independent server.
Right, so better hardware utilization.
Definitely. Second, isolation. It provides protection. If one VM crashes or gets infected with malware, it generally won't affect the other VMs running on the same physical hardware.
That's good for security and stability.
Absolutely. Third, aggregation. You can combine multiple physical resources, like storage drives spread across different machines, into a single logical pool that's much easier to manage and allocate.
And I heard you mention dynamics and management ease.
Yeah, dynamics is a big one. It enables things like fast allocation of resources, easy changes, mobility. You can actually move a running VM from one physical server to another with no downtime, and load balancing to optimize performance.
Wow, moving a running machine.
Yep. It's called live migration. And ease of management comes from simplifying how you distribute, deploy, and test software and updates. All of this lowers operational expenses.
And cost efficiency must be huge.
It's a major driver. You minimize hardware costs because you're running multiple virtual servers on fewer physical machines. This dramatically increases the utilization of each physical server, and they're not sitting idle as much. Plus, you can consolidate workloads that don't need much power onto shared hardware. And think about disaster recovery.
Ah, yeah, you mentioned that.
Imagine having your critical server environment essentially as files these VM images. If your primary site goes down, you can potentially bring those VMs back up very quickly at a secondary site instead of having to rebuild physical servers from scratch.
That flexibility sounds incredibly powerful. Can you maybe break down the core concepts of server virtualization a bit more? Like, how does it actually work under the hood?
Sure. So at the base layer, you have the physical hardware. Running directly on that hardware is usually either the host OS or, more commonly in data centers, a hypervisor.
Okay, what's the hypervisor?
The hypervisor is the key piece of software. It's what creates, runs, and manages the virtual machines. Think of it as the traffic cop directing resources between the physical hardware and the VMs. Above the hypervisor, you run your guest OSs. These are the operating systems like Windows Server or Linux running inside each virtual machine.
And are there different kinds of hypervisors?
Yes, primarily two main types. Type 1, often called bare metal hypervisors, run directly on the physical server hardware. Examples are VMware, ESXi, Microsoft Hyper-V in its server role, or Xen. These are generally used in data centers for best performance and scalability.
Okay.
Type 2, or hosted hypervisors, run on top of a conventional operating system, like running VMware Workstation or Oracle VirtualBox on your Windows or Mac laptop. These are great for testing, development, or running different OSs on your desktop, but usually not for heavy-duty server workloads. There's also a sort of hybrid, sometimes called Type 0, like Linux KVM, which integrates hypervisor capabilities directly into the host OS kernel.
Interesting distinction. So that covers server virtualization. What about storage virtualization? How does that fit in, especially in data centers?
Right, storage virtualization is also huge. In data centers, disks are often kept external to the servers themselves in dedicated storage systems. This allows multiple servers to access the same data and ensures data access even if one server fails.
So not just drives inside the server box.
Exactly. Historically, you might have had just a bunch of disks, or JBDs, which were simple enclosures but could be hard to manage and didn't offer much redundancy. So disk arrays, or storage area networks, INS, evolved. These offer intelligently managed pools of disks with features like RAID for redundancy built in.
And virtualization adds another layer.
Yes, storage virtualization abstracts the physical storage. The benefits are massive. It can make remote storage appear as if it's locally attached to a server. It spreads data across multiple physical disks for better reliability and performance. It allows different operating systems, Windows, Linux, Unix, to seamlessly use the same underlying storage device.
There's more flexibility again.
Huge flexibility. It dramatically increases disk utilization because you're pooling resources. It enhances availability with multiple paths to the data and redundant storage components. It's fundamental for modern disaster recovery and continuous online backup strategies. And there are clever features like thin provisioning.
Thin provisioning, what's that?
It lets you create a virtual disk that appears, say, 1 terabyte in size to the operating system, even if you only allocated maybe 100 gigabytes of actual physical disk space to it initially. The system then allocates more physical space automatically, only as the virtual disk actually fills up. It avoids wasting space up front.
Very efficient. Okay, so we have virtual servers, virtual storage. Is there a standard way to package and share these virtual environments? Like a zip file for VMs?
There is. It's called the Open Virtualization Format, or OVF. It's actually an ISO-IX standard now. It's designed for distributing software packaged up as a ready-to-run virtual appliance, which is essentially a pre-configured virtual machine image.
So it's portable.
Exactly. Think of OVF as the universal blueprint or container for virtual machines. An OVF package is independent of the specific hypervisor or processor architecture. It contains an XML file, the .ovf file, with metadata like hardware requirements, networking info, security certificates, and then the actual virtual disk files, often in formats like .vmdk.
And who supports this?
All the major players: VMware, Microsoft, Oracle, Citrix, IBM. They all support OVF. It means you could potentially create a virtual appliance on one platform and deploy it easily onto another, which is great for avoiding vendor lock-in and simplifying distribution.
That's a really comprehensive look at servers and virtualization. Okay, let's switch gears now to another category of powerful machine that sort of sits in a unique space, maybe between a high-end desktop and a server, the workstation. What exactly is workstation built for?
Workstations are true powerhouses, but for very specific, specialized tasks. They are high-performance machines explicitly tailored for applications that demand really significant computational power and often advanced graphics capabilities.
So definitely not just for checking email or browsing the web then. What kind of intense tasks are we talking about?
Exactly. They are pivotal for professionals doing things like 3D modeling and animation, high-resolution video editing, computer-aided design or CAD, complex graphic design, rendering photorealistic scenes, heavy scientific computing, or simulations.
Right. Things that would choke a regular PC.
Pretty much. If you're dealing with multi-GPU setups for editing 4K or even 8K video or running complex engineering simulations, a workstation is often essential.
And what kind of hardware makes a workstation capable of tackling these demanding jobs? What defines it?
Well, they feature powerful multi-core CPUs. Often you'll find the same enterprise-grade chips we see in servers, like high-end Intel Xeon or AMD Threadripper processors, a non-pro version sometimes, offering lots of cores and cache.
And lots of RAM, I assume.
Absolutely. They're equipped with ample memory, very often ECC RAM, just like servers, to ensure smooth multitasking and error-free processing when dealing with massive data sets. But the real differentiator for many workstations lies in their graphics capabilities.
Ah, the GPU.
Yes, they utilize dedicated professional-grade GPUs. Think NVIDIA Quadro, now RTX A series, or AMD Radeon Pro cards. These are specifically optimized not just for high frame rates like gaming cards, but for precision, stability, certified drivers, and performance in high-end rendering and visual processing within professional applications.
So how does that differ from, say, a high-end desktop that might have a powerful gaming GPU, or even from a server?
Good question. Desktops typically use consumer-oriented CPUs, your Intel Core i7s, i9s, AMD Ryzens, and consumer-grade GPUs like NVIDIA GeForce or AMD Radeon RX series. These are great for gaming and general productivity, but maybe not certified or optimized for professional CAD or rendering software. Servers, as we said, also use Xeon or EPYC CPUs and prioritize stability and sustained performance. But their GPU needs vary wildly. They only need high-end GPUs for very specific applications like AI training or scientific computing, not usually for driving displays or real-time visual work.
Right.
Workstations often undergo something called ISV certification. That's Independent Software Vendor Certification. It means the hardware vendor, like Dell, HP, Lenovo, works with software companies like Autodesk, Adobe, Dassault Systems to test and certify that specific workstation models run their professional software reliably and perform optimally.
So you get guaranteed compatibility and stability.
Exactly. That's a key reliability factor and selling point for professionals who depend on that software for their livelihood. You pay a premium, but you get peace of mind that your expensive design or simulation software will just work.
That makes the distinction much clearer. Okay, and speaking of software, let's touch on a common point of confusion. The operating system choices, specifically Windows Desktop versus Windows Server. They look similar sometimes, but what are the key differences?
Yeah, this is a common one because they shed a lot of underlying code, but their intended purposes and capabilities are fundamentally different, much like the hardware differences we've been discussing.
Right, so Windows desktop OSs like Windows 10, Windows 11, that's what you typically find on laptops and standard desktop computers. They always include a graphical user interface, the GUI, making them user-friendly. They're optimized for desktop processors and hardware like those powerful gaming graphics cards. And they're generally less expensive than the server OS licenses.
True, however, they come with some significant limitations if you try to use them for server-like tasks. The home versions, for example, typically can't join a corporate domain, which is crucial for centralized network management in a business.
Right, user accounts, policies.
Exactly, and they lack the ability to install core server features or roles like Hyper-V for robust virtualization or DNS and DHCP server roles for managing network infrastructure. Even the professional versions have limitations, for instance. Windows 10 Pro officially supports up to 2 terabytes of RAM, which sounds like a lot, but high-end servers and workstations can go much higher.
Okay.
If you've ever tried to set up, say, a simple shared network drive on a regular Windows desktop for a small team, you probably ran into connection limits or management hassles pretty quickly. It highlights why a server OS is purpose-built for those kinds of multi-user, always-on environments. Desktop OSs are best for individual tasks, video editing, coding, general productivity, but really not recommended for critical business processes that need to run continuously and reliably.
So how do Windows Server operating systems like Windows Server 2019 or 2022 address these limitations?
Windows Server typically runs on that server-grade hardware we discussed, using enterprise components like Xeon CPUs, and it's specifically optimized to take full advantage of that hardware, more cores, more RAM, etc. Crucially, it allows you to install those essential server roles. Active Directory for creating and managing domains, Hyper-V for enterprise-grade virtualization, robust file and print sharing, web server capabilities with ICS, DNS, DHCP, all the building blocks for a business network.
And you mentioned earlier it can run without a graphical interface. That sounds pretty different for Windows.
It can, yes, and that's a key flexibility often used by IT pros. It can run in server core mode, which is just a command line interface.
Why would you do that?
Several reasons. It minimizes the installation footprint, meaning less disk space used. It significantly reduces the attack surface for security threats. Fewer components running means fewer potential vulnerabilities to exploit. And it generally requires fewer patches and reboots compared to the full GUI installation.
Interesting. So more secure and stable, potentially.
Potentially, yes, if managed correctly. Now, there are some very specific niche instances where you might install Windows Server OS on desktop-grade hardware, maybe if you need a particular feature but redundancy isn't critical, or if you need access to specific desktop hardware like a high-end audio card for some reason, but that's really an exception, not the rule. It's designed for server hardware.
Okay, so after exploring all of this, PCs, servers, workstations, NAS, virtualization, operating systems, when you're standing at that crossroads trying to choose the right machine, how do you actually make the call? It really seems to boil down to balancing performance, cost, and maybe a physical form factor.
Absolutely. Those are the key axes. Let's quickly compare them on performance and scalability. For raw CPU performance, generally think desktops are moderate, workstations are high, and servers are typically very high, especially with multiple processors.
And GPU?
GPU performance is standard for desktops, high for workstations, focused on professional apps, and varies wildly for servers from basic integrated graphics up to multiple high-end compute GPUs, but it's very application-specific.
Scalability, how much can they grow?
Desktops have limited scalability.
Yep.
Workstations offer moderate scalability, maybe adding more RAM or another GPU. Servers offer high scalability, not just vertically, making one server bigger, but horizontally you can cluster many servers together for massive performance and redundancy, essential for critical enterprise apps or things like deep learning.
And reliability.
Huge difference here. Desktops offer standard reliability. Workstations with ECC RAM and ISV certification offer high reliability. Servers, built with redundant components, ECC, robust management, offer very high reliability. They're designed for uptime.
Okay, now the big one, cost, because that's often the first hurdle.
Right, initial cost. Desktops are generally low, workstations medium to high, and servers are typically high to very high. But you have to look beyond that initial price tag to the total cost of ownership, or TCO.
Ah, the ongoing costs.
Exactly. TCO is probably medium for desktops, high for workstations, and potentially very high for servers due to ongoing maintenance contracts, software licensing, higher energy consumption, and often the need for specialized cooling or environments. Power efficiency related to that is generally best on desktops, medium on workstations, and often lower on servers, especially when they're working hard 24/7.
Makes sense. Finally, let's just touch on form factor and design. This can be really critical depending on where you plan to put these machines, right? Under your desk versus a dedicated room.
Definitely. You can get small form factor desktops and even mini workstations now that pack a surprising punch into compact designs, great for space-constrained offices or homes. Servers, conversely, are usually rack servers, designed for those standard 19-inch racks to optimize space, airflow, and cabling in data centers or server closets. And for even higher density, you have blade servers, which slot into a chassis with shared power and cooling, offering maximum compute power in a small footprint.
And just quickly, what about data integrity and connectivity across these categories?
Data integrity is absolutely paramount for servers. Features like RAID configurations, ECC memory, and comprehensive backup solutions are standard. Workstations often offer enhanced data integrity too, especially with ECC RAM, depending on the professional needs. Desktops provide, well, moderate data integrity. It often relies more on the user implementing backups.
And getting connected.
Servers offer robust connectivity, usually multiple high-speed network ports, optimized for handling significant network traffic. Workstations also provide advanced connectivity options suitable for demanding applications like large file transfers or network rendering. Desktops provide basic, general-purpose connectivity. And for remote access, servers and workstations typically offer much more advanced built-in remote management capabilities compared to the basic remote desktop features on a standard PC, which is crucial for IT support and distributed teams.
So, after all that, what does this really mean for you, our listener? We've certainly covered a lot of ground today, haven't we? From the basic definitions, digging into the nitty-gritty hardware differences, the power of virtualization, I think it's really clear that choosing the right machine isn't just about picking the most powerful one off the shelf.
Not at all.
It's about truly understanding the specific job you need it to do that marathon or that sprint, and then selecting the tool that's best suited for that exact task.
Yeah, and if we kind of connect this to the bigger picture, it does raise an interesting question for the future, doesn't it? In a world where, all our devices are becoming increasingly versatile and powerful, how will these fundamental roles, server, workstation, personal computer, how will they continue to evolve? And what sort of new hybrid solutions might emerge to meet our ever-growing demands for data processing and storage?
That's a fantastic thought to leave everyone mulling over. And just before we wrap up this deep dive, we do want to remind you about our sponsor, Stonefly. For those who are serious about data storage, reliability, and security, Stonefly is offering a 100 terabyte immutable and air-gapped SSO NAS for just $8,995. That's a really compelling solution if you're looking to securely manage large amounts of data with truly enterprise-grade protection features. Something to check out at stonefly.com.